Good afternoon, good morning, good evening from wherever you may be. My name is Matthew Morin, and I'm a Senior Product Manager here at Cylance. Today, we're going to be talking about CylanceOPTICS version 2.4, our latest release of the product. We'll talk about an overview of the product, talk about how CylanceOPTICS plays alongside CylancePROTECT, the visibility that you gain with the product, and some use cases. We'll talk about the key components of CylanceOPTICS. We'll talk about the new pieces of CylanceOPTICS in version 2.4 that we recently introduced. And then we'll talk about some additional use cases and some other analysis that we've had done of the product. So before we get started, at a high level, what is CylanceOPTICS? CylanceOPTICS is the EDR portion, or the endpoint detect and response portion of BlackBerry Cylance's AI platform that leverages and augments the prevention technology delivered by CylancePROTECT. This allows us to provide consistent visibility to endpoints regardless of where they may exist in your environment. It couples really nicely with CylancePROTECT and is integrated completely with our Threat Zero solution implementation services, as well as our CylanceGuard proactive managed detection and response offerings. So what does this actually look like in action? If you're a current CylancePROTECT customer, you may be aware of the great pre-execution prevention technologies present in that product. But you might be asking yourself sometimes, how did this piece of malware get on my system to begin with? Sure, CylancePROTECT may have prevented it or stopped it from executing, but what is the root cause analysis of that? Or if you're in more complex or larger environments, you might be dealing with malicious actors who are not using malware to move around in your systems, or who might be using living off the land attacks to maintain persistence and conduct malicious actions in your environment. So the way that I like to think about this is, at a high level, CylancePROTECT looks at the content of files. It looks at a portable executable file, it dissects it, and puts it into its mathematical models to determine whether or not that's malicious or suspicious. Again, that's oversimplifying what CylancePROTECT does at its core, but at the end of the day, it's designed to stop malware from executing on systems, in addition to the script control and memory protection capabilities that it has. Where CylanceOPTICS comes into play is looking agnostically at a whole system, looking at all the files that are being created, all the processes that are being started, the registry keys that are changing, the network connections that are being established, and keeping an eye on every single one of those changes that happens on an endpoint. With all of that data, there's a lot of actions that we can take as we're seeing that live stream of data on the endpoint. We can run it through a feature called Context Analysis Engine to do live response and detection of malicious actions. We can store it in a database for later querying or root cause analysis. So you hear me mention the processes and the files and the registry keys and network connections. And what we'll talk about later on in the presentation is the additional visibility that we added in with CylanceOPTICS version 2.4. Now, the nice thing about playing in the EDR space is that the analysts at Gartner have put together a set of guidelines for what an EDR solution should be providing to customers, what you should be looking for in your EDR solutions to make sure that you're getting the most bang for your buck. The first area is detection. First and foremost, EDR is designed to detect malicious activity on endpoints that traditional antivirus solutions or even next-gen antivirus solutions wouldn't be designed to look at. The next piece is investigation. Your EDR solution should be able to provide you contextual information so that you can later search it or do root cause analysis or further conduct investigations on those systems and the data that was recorded by the EDR solution. Next is containment. Utilizing various technologies, an EDR solution should be able to contain or isolate a device or set of devices from being able to communicate with other ones, to contain processes, and generally stop a malicious actor from moving laterally throughout the network. And the final piece is remediation. EDR solutions must be able to provide a mechanism for systems that have been compromised or have been attacked to be reset to a specific point in time, to undo the actions that a threat actor was taking, or to otherwise remediate an attack that happened on an endpoint. So where does CylanceOPTICS play into each of these pieces? The first and foremost differentiator with CylanceOPTICS, and one of the areas that we focus on most with this product, is providing prevention technologies and capabilities. We focus on preventing the unknown unknowns. Focus on preventing the things that malicious actors are doing that antivirus signatures might not catch. Focus on things that don't have indicators of compromise for. And the reason why we do this is because we already are piggybacking on top of CylancePROTECT, which has a significantly high efficacy rate for detecting malware and preventing memory-based and script-based attacks. And what this boils down to is, on an endpoint agent, if we have the visibility into processes, into files, into network activity, or any other activity that's happening on that system, if we see something bad that's happening, at our core, we believe that we should be able to stop that malicious action from occurring. So rather than recording data and setting it up to a cloud service and having a cloud analytics service look at this data kind of out of band, we do all of our logic or detection logic and response logic locally on each endpoint. This allows our endpoints to protect themselves as well as respond to threats in almost real time. And the reason for this is, if we can stop as much bad stuff from happening on the endpoints, this creates more time for your security team to go and do more proactive security practices. So rather than responding to threats and doing investigations, you have a level of comfort knowing that CylancePROTECT and CylanceOPTICS are both taking preventative actions on those endpoint agents to keep themselves safe, regardless of if they are connected to our cloud console, or if they have a network connection, or if they are connected to your domain. To align to some of the other areas that Gartner outlined in their EDR requirements, we're going to walk through a quick set of features and capabilities that are present within CylanceOPTICS. The first area that I want to talk about is a feature that we call Context Analysis Engine. Context Analysis Engine is our real-time detection engine that sits locally on the CylanceOPTICS endpoint agent. This is a home for machine learning models, as well as custom detection logic that is written by Cylance's world-class threat research team. It's important to note that this engine houses all of its detection and response logic locally on the endpoint. So rather than streaming data up to a cloud service and requiring a cloud service to analyze data, the endpoint agents are smart enough to protect themselves regardless of where they exist, whether or not they have a network connection, or whether or not they are connected to your corporate or enterprise network. With this logic and with this engine, it is extremely extensible to both us at Cylance as well as our partners and customers. From a customer's perspective, what this looks like is a constantly evolving set of threat detection logic that is released by our threat research team. For those of you who are familiar with MITRE ATT&CK and the MITRE ATT&CK framework and the attack evaluations, there is a prepackaged set of detection logic that maps directly into the MITRE ATT&CK framework. This logic is able to constantly evolve, very similar to how the attack framework continues to evolve and expand. The other nice piece of being at Cylance is our incident response teams are constantly tracking novel threat actors and attacks that are being seen in the wild. They can then take this data seen from real-world scenarios or from research that's being conducted and import that logic and detection capabilities directly into the product and expose that to all CylanceOPTICS customers at a moment's notice. Context Analysis Engine is also exposed completely to our customers and partners, which means that if you are a customer or partner, you get access to the same documentation in the same engines that our threat research and incident response teams do to create your own custom logic inside of the product. What this means is you don't have to rely specifically on Cylance's machine learning models or our default provided detection logic. You can create your own custom logic based on IOCs that you may be receiving, based on other tools that you have internally in your environment, or any other information that you may want to gain visibility into on your endpoints. This is really great in the sense that our incident response team uses this in many cases to go and track advanced actors and various APT groups that they may be responding to in specific environments. In some cases, we've been able to create as much as 30 pieces of logic to look for individual threat actors in an environment and then respond to those events automatically. Response actions include terminating processes, logging off users, deleting registry keys, deleting files. Anything that would be associated with that malicious or suspicious activity is all exposed through Context Analysis Engine. Again, that all happens locally on that endpoint with or without a network connection. Now, while we'd like to talk about the prevention capabilities within CylanceOPTICS and how we're able to prevent threats and respond to threats automatically, there are still plenty of use cases on the EDR side of things to be able to answer questions. Has this been seen in my environment before? Has this hash been seen on any of my endpoints? Has this command line ever been executed on those systems? Or has this file extension been seen in any specific directories? To fulfill those use cases, we have a feature called InstaQuery. InstaQuery is designed to answer that question. It is a lightweight analytics tool that instantly queries each of the endpoints in an environment, aggregates those results back, and presents them in a way for analysts to easily view that data and conduct analysis on it. For example, in one case, we had a ransomware outbreak in a global environment. The customer and our incident response team were able to use InstaQuery to search their entire global environment by region. In this case, we were dealing with an infection in the United States, but they also had a presence in Europe, Asia, and various other countries throughout the world and continents throughout the world. And what we're able to determine with InstaQuery within a matter of seconds is that all of the indicators of compromise, in this case, the file extension for a piece of ransomware, was only seen in the United States, and then the customer was able to focus their remediation and response efforts directly inside of the United States, rather than dealing with other countries and getting people up and other operators up from around the world. InstaQuery works by querying endpoints using our real-time communication channel known as Cement, which is our bidirectional WebSocket that communicates from our cloud console down to our endpoint agents and back. This allows us to very rapidly command and control the endpoints regardless of where they are in the globe. They do not have to be connected to your corporate network. They do not have to be connected to a VPN. Anything that has access to Cylance's cloud services will have the ability to query and talk to our cloud services. The next logical place to move after finding something malicious in your environment or conducting the InstaQuery results is, how did this get onto my device? Where did this come from? What did it do? What else should I be aware of that may be related to this attack or this suspicious action? Now, the first piece of this is what we call autofocus. And autofocus is a capability that ties CylancePROTECT and CylanceOPTICS directly together at the hip. When CylancePROTECT sees or prevents a piece of malware or a memory event, it can tell the CylanceOPTICS agent that it just saw something malicious happen. When CylanceOPTICS receives that message and receives that alert from CylancePROTECT, CylanceOPTICS will automatically go and gather the contextual information that it knows about around that specific file, around that specific process, or around any specific indicators that CylancePROTECT is sending us. We'll then generate a contextual timeline of events that then get automatically communicated up to the Cylance console, where they can be viewed for further analysis. Focus View also works on a manual basis. Rather than dealing with strictly pieces of malware or memory events, a focus view can be conducted on any event that CylanceOPTICS sees on an endpoint agent. For example, if a process is starting with a specific set of command line parameters, an analyst could issue a focus view on that particular process and see everything that that process has done on the endpoint agent, including any files that it created, any network connections that it established, or any other processes that it started. Similarly, an analyst could also conduct a focus view on a file and determine the lifetime or lifespan of that file. Now, with CylanceOPTICS, we talked about the ability to see processes and files and network connections. And it's not just seeing those individual instances. CylanceOPTICS also records the finite and very small details related to each of those events. For example, on a process, we record the process owner, the process's IDs, the command line arguments, the file signature information. For network activities, we record the source and destination ports, the source and destination IP addresses. For files, we get the file hashes, the file owners, the file sizes, things of that nature. It's not just the single events. And when you tie all of this together in a focus view, it allows you to see the full story of what was happening without receiving a mountain of data back. The idea of focus view is to provide a clear, concise vision of what is happening on an endpoint without overloading analysts. So rather than querying a database and receiving tens of thousands of events back that you need to sort through, Focus View intelligently gathers data off of those endpoint agents and responds back in a very clear, concise set of data. This allows analysts of any skill level or of any tier to be able to look quickly at a chain of events and determine if something is malicious or suspicious. From here, the analyst can continue their investigation by doing additional InstaQueries to determine the overall impact or spread of this. And they can continue to gather these pieces of data together to formulate a response. For example, a detection alert may have only triggered for a process, but there may be additional files or supporting files or configurations that were introduced to the system by a piece of malware. Focus View allows analysts to look at that chain of events, analyze everything that happened, and then start to put together a plan of response and remediation for that specific attack. And speaking of response, the last group of features that I'd like to talk about for CylanceOPTICS is packages and playbooks. Package deployment in CylanceOPTICS allows for complex actions to be taken on endpoints at scale on demand. Essentially, what package deploy allows us to do is execute arbitrary applications on CylanceOPTICS endpoints. It allows us to collect forensic artifacts, and it allows us to do pretty much any number of actions that could be scripted on an endpoint agent. This can be done, again, on demand, on a single device, on multiple devices, or a single or multiple zones in your environment. Package deployment also couples really nicely with a feature that we call Playbooks. So for example, if I have packages in my console that allow me to collect browser history files or program execution records or conduct a full memory dump of a system, package deploy allows us to do that on demand. Package playbooks allow us to tie together context analysis engine into the scripting engine as well to take complex actions as soon as an event is seen. For example, if I have a detection rule that sees if Powershell is trying to download a file, for example, I could associate a playbook with that detection rule, and anytime that I see PowerShell trying to download a file, I can go and automatically collect a set of PowerShell logs. I could go and automatically collect a browser history file, and I could automatically go and collect a memory dump. That way I get the most clean and most up-to-date forensic information on the system without a single keyboard or keystroke ever being typed from one of my analysts. Now, the other nice piece of packages and playbooks is that, very similar to CylanceOPTICS context analysis engine, the scripting engine and the logic for writing CylanceOPTICS packages is exposed to our customers and our partners. So what this means is that anything that you can think of that you would want to script on an endpoint, whether it's running applications, putting additional configuration files on your systems, gathering additional information, changing system configurations, this can all be done through a CylanceOPTICS package, which you can upload into our console and then deploy down to your CylanceOPTICS agents, all through our console. Now, in terms of some use cases, this gets really interesting because what we have built this for was originally threat detection and threat response and threat analytics. However, we've seen some of our customers and some of our partners start to expand their use cases beyond threat detection and threat prevention with context analysis engine and packages. For example, I know of one customer who has taken a CylanceOPTICS context analysis engine rule, modified it to look for a specific application starting. This is an application that they deem to be a high risk in their environment. It's commonly exploited. It's not something that they're comfortable with having in their environment. But it's also a trusted application that no antivirus solution would really ever catch. So they built a context analysis engine rule that looks for the specific process, name or path or hashes being started. And then they also built a custom package that they turned into a playbook that will automatically uninstall that application when it runs. So you're not only talking about threat detection and threat prevention, but you're also talking about the potential for application management and other extremely flexible use cases that typically wouldn't fall onto an EDR product. The really interesting piece about this is just how flexible this logic is. It's not just Cylance that can provide this logic to your endpoints. This is something that can go directly down, that you can have your analysts working on, that you can have your MDR solution working on. All of these features are also exposed via our API. So everything that you see in the Cylance console, all the interactions for running an InstaQuery or creating a context analysis engine rule or executing packages is all exposed via the same API that we build our services on top of. So in theory, if you wanted to, you could rebuild our console with your own code. But what this allows you to do is deeply integrate with almost any service that's out there that can hit our API. If there's custom tools that you want to build or custom automations that you want to build, you can command and control your endpoints through our API. It's not just an API to get data out of, it is a full bidirectional API. Now, with that being said, and all the features that we currently talked about, let's talk about where OPTICS 2.4 plays a role into each of these features and how CylanceOPTICS version 2.4 benefits you and continues to extend on this platform that we have. So at a high level, what's new in CylanceOPTICS version 2.4? The first main point is we get double the visibility into endpoints. Before, we had about 5 different what we call sensors that allow us to see data. Those are the things that allow us to see the processes that are starting or the files that are being created. We added in about 5 new sensors to the CylanceOPTICS agent, which essentially doubles the amount of data that we can see on those endpoint agents. With that additional visibility and with those new data types that we're able to see on the endpoint agents, we get about 5 times the addressable space with context analysis engine. That means that our threat research team can continue to build world-class detection logic tracking some of the most advanced actors in the world, and allows our users and customers to continue to build their own deep integrations into our platform with their own logic. These new artifacts and facets, or these new pieces of data, are all exposed via InstaQuery, and they also present themselves into focus view. So what are these new data points and what can you expect to see out of them? The first big one that we added in is DNS visibility. This allows you to see which processes are resolving domains and then analyze the resolved addresses, the resolved record types, and more. This is really interesting because it does not just allow for you to see what web browsers are doing, but this allows you to see any process that is resolving DNS requests or making DNS requests. So if you're dealing with a piece of malware in your environment that's calling out to a command and control server, and you know about that domain, or if you know about IP addresses that specific domains are resolving to that you deem to be malicious or suspicious, you can see that with Context Analysis Engine. You can write response logic that will go and terminate any processes that match that logic. You can query it with InstaQuery, and you can also see it inside of Focus View. So you get a much richer view into what is happening on the network side of things. Now, historically or traditionally, in order to get this sort of DNS visibility, you either have to have another endpoint agent that specifically looks at DNS requests, or that device has to be attached to your corporate network so you can log and audit that outbound network traffic, or it has to communicate to one of your DNS servers. This eliminates all of those requirements. The resolution and tracking happens directly on the CylanceOPTICS agent, and it does not require that those devices be connected to your corporate network. This is seeing exactly what the operating system sees in terms of those resolutions. The next piece is PowerShell introspection. Many products and many tools out there will claim that they can see almost anything that PowerShell is doing in an environment. It's a huge attack surface. Malicious actors will continue to expand their footprint and their attack techniques that utilize PowerShell. However, many of the products that are on the market, and up until the release of Optics 2.4, many of the products are looking specifically at the command line parameters that are being passed into PowerShell. And this is really nice because that's how a lot of scripts start PowerShell, as they pass in command line parameters to it. Unfortunately, as malicious actors have continued to evolve, they've found that many solutions and tools out there lose visibility into PowerShell if commands are typed directly into a PowerShell interpreter, are typed directly into the PowerShell ISE, or if they're typed directly into .ps1 files and executed that way. What this new sensor allows CylanceOPTICS to do is see virtually any PowerShell argument, command, or module that is loaded. It does not need to be passed specifically through the command line. It can be also, lets us get visibility into the PowerShell interpreter itself. So if I'm running an invoke web request command directly inside of the PowerShell interpreter, I can now use Context Analysis Engine to analyze that PowerShell script, to analyze what that PowerShell interpreter is doing, and determine that it's trying to download a file from inside of the interpreter, where I wouldn't have visibility into that before. The same goes for WMI. WMI is still a little less prominent than PowerShell from what we're seeing from our threat research team. However, WMI is still being commonly used by some of the more advanced actors to establish and maintain persistence on endpoint agents. Historically, again, everything would be done through command line detection, looking at how WMIC is being started. But if the WMI interpreter is being interacted with directly through PowerShell or through another Windows API call, a lot of tools, including CylanceOPTICS historically, would lose visibility into that WMI interpreter being called. This new sensor allows us to hook into the actual WMI interpreter and see things like the WMI consumers, the event filters, and any referenced files. Again, this all goes through Context Analysis Engine, is able to be queried via InstaQuery, and also presents themselves inside of Focus View. We added in a portable executable parser into the CylanceOPTICS Context Analysis Engine. What this does is very similar to what CylancePROTECT does when it sees a file on a system. CylancePROTECT, when it sees a file, will rip it apart and break it down to some very finite and atomic pieces of data. We took that same concept and almost the same parser that CylancePROTECT uses and allows that data, instead of being fed into a mathematical model, allows us to feed it through context analysis engine and use CylanceOPTICS to conduct static analysis of executable files locally on the system. This allows our teams to look at file version information, functions that exist in the executable file, import tables, and a bunch of other really finite data of executable files themselves. We added in private address RFC 1918 or RFC 4193 address space visibility. Historically, we would filter out those connections for the sake of maintaining a higher fidelity set of data on endpoint agents. We do now allow for a configuration option where you can see network communications destined to and from RFC 1918 address space. This is great for tracking lateral movement and some other internal attacks that may be occurring between endpoints locally on your network that aren't necessarily communicating with public IP addresses. And the final thing that we added in Optics version 2.4 is Windows logon event visibility. We allowed us, we're hooking into the Windows event log providers for the security audit provider, the kernel 32 audit provider, and a couple other of the security providers in Windows event logging that allows us to record these data points directly into a context analysis engine. So to break this down a little bit, because it's a lot of information and a lot of really great, rich data that we're getting, what questions do these new sensors allow you to answer? What do they allow you to ask, and what data do they answer for you? For example, on the DNS request, you can query for a question name and ask the question, has my domain .net ever been seen in my environment? Or you can query by record value. Has a domain ever resolved to this IP address? And this works out really nicely because, again, this queries across your environment with these with devices that have this data enabled, and it will pull all of that data back automatically for you, regardless of where they are in the world. On the PowerShell trace side of things, you're able to answer the questions or ask the questions, show me all matches for event ID 4101, or answer the question, has a script ever executed with this text in it? Or has a payload or module ever executed with this text in it? And a similar piece for WMI. Has a WMI consumer ever been created with this text in it? Has an operation ever executed with this text in it? It allows you to query all of this very rich data that we previously never had access to before. And the same goes for Windows Event. Show me all events that match the event ID 4624 for logon events, or show me all events from the security audit provider, or show me all log on and log off events. Now with this additional set of data and with these great sensors and the flexibility of the platform, what are some of the experts saying about CylanceOPTICS? What are some of your peers saying? What are some of the analysts saying about this? The first, from Gartner Peer Insights, Cylance is the best of breed in threat detection and threat prevention. Since installing CylancePROTECT and CylanceOPTICS, we can sleep at night. This means that your security team is feeling more comfortable with their environment. They know that they have a strong set of detection and prevention logic stopping as many threats as possible, and that if, in the rare event that an event does happen, if a piece of malware does execute, if a malicious actor does compromise a set of credentials, there's a supporting set of data to quickly and efficiently triage that, determine what happened, and start to pull together a response story. Forrester also released the Total Economic Impact Report of CylancePROTECT and CylanceOPTICS in May of 2019. And in the study, Forrester was able to determine that CylanceOPTICS improved the security team's productivity by 10%, reduced lost time by 95%, and reduced the expected cost of a major security breach by 25%. This is all because CylancePROTECT and CylanceOPTICS play extremely well together. We piggyback off of each other's technologies and can provide a true prevention solution to our customers, rather than playing the traditional detect and response game where you need to see the data, have humans analyze it on the cloud services, and then let you know something that happens after the fact. CylancePROTECT and CylanceOPTICS have so much technology and so much confidence in that technology that we can stop malicious actions as they occur on endpoints before bad can ever be done. I used to be a pen tester. I used to be an incident responder before I moved into product management. And if you give me 2 seconds on a system, I'm going to have 5 different ways that I have persistence on that system. It's going to be too late if you're not preventing bad stuff from happening, if you're not preventing those malicious applications from running. This is the only true path forward in terms of protecting your endpoints. And CylanceOPTICS and CylanceOPTICS version 2.4 helps you move that needle forward towards protecting your endpoints and gaining that ultimate visibility and prevention strategy. I see that there's a few questions. Is Optics getting FedRAMP, ETA? Yes, all of Cylance's products and services are FedRAMP certified. If you're operating in the AWS GovCloud regions, CylanceOPTICS is available in those regions. What is the Cylance Cloud Services? BlackBerry NOC, is that BlackBerry NOC, Azure, AWS, or all? Cylance's cloud services are in AWS right now. Will Cylance be publishing information for recommended CA rules for Windows and Mac environments? Yes, there is a set of knowledge base articles on our support website that talk about the rules that we have available for Windows and Mac. And we are working with our Threat Zero team and our Cylance Guard team to publish a bit more of a detailed guideline for detection configuration and what each of those pieces of logic provide to you. Performance of the Optics agent and how big it compares to CylancePROTECT. So CylanceOPTICS is actually a smaller install file than CylancePROTECT agent. We typically sit at around somewhere in the ballpark of 70 megabytes of memory when we're idle. That can fluctuate up and down depending on which detection logic we're working with and how many events are happening on the system. We do reserve about a gigabyte of data or so per endpoint agent to store that local forensic data. And CPU cycles will generally sit idle at about 1%. And will spike up every now and then depending on if we have to ingest data or if queries are being run. But generally, it's a pretty quiet black box flight recorder that sits in the background. How is the new data going to affect the amount of information kept in our tenant? Right, so that's kind of one of the big questions that we've been getting from current customers and current partners about Optics 2.4. The new sensors won't impact the data retention for your tenant. InstaQuery and focus view results are still currently retained indefinitely. Detection events are still expire after 30 days. So the new data that we're sending up, whether it's via focus view or InstaQuery, won't impact that. We do our data limits on time and not by size. So if you enable the new sensors, you don't have to worry about expiring old data that may exist in your tenant. Oh, good question. How do we enable the enhanced logging visibility? The new logging or the new sensors are exposed in device policy in the CylanceOPTICS settings tab. If you go into that tab of device policy, there will be, I think, 7 new checkboxes for each of the new sensors. These sensors can be controlled individually of each other, so you don't have to have all of them on. If you only wanted to have just DNS visibility on, for example, you don't have to turn on all the other sensors. The other nice piece is this is done per device policy. So if you want specific sensors on in one part of your environment, but not the other, you can control that via device policy. It's not an all or nothing type thing. Good question. Does CylanceOPTICS track file changes and or movements, like if several files get modified or deleted? Yes, CylanceOPTICS does track file movements. We track every single file create, every single overwrite, every single file write, every single file rename. So you can see pretty much everything outside of file reads that happen on endpoint agents related to files. Thank you very much for attending. I hope this was useful. Have a great rest of your week. Thank you.